Hello and welcome to York Universe, the astronomy and astrophysics radio podcast written and presented by the students, faculty, alumni, and friends of York University. You'll find us now wherever podcasts are distributed. I'm Sana Withers, I'll be one of your hosts this evening, and I'm joined by Dr. Elena Hyde. We're broadcasting live from the Allan Carswell Observatory at York University in Toronto, Ontario, Canada. York Universe broadcasts live every Monday night at 9 p.m. local Toronto time or Tuesday morning at 1 a.m. Universal time. We broadcast live on our YouTube page, York U Observatory, and run in concert with our online public viewing program run by the Observatory team. To navigate to the live show or to find out more about us, please check out our website at yorku.ca/science/observatory and follow the links to the online public viewing broadcast to join the live chat on YouTube. For any questions or comments, or if you have on past shows, or if you have any suggestions for future topics, please send us an email at observe@yorku.ca. You can also always connect with us on Instagram at the handle @YorkUObservatory and on Facebook at Allan I. Carswell Obs. All of our programs are free, but if you would like to make a donation, please see our website at yorku.ca/science/observatory. Our observatory team will be monitoring the chat room for questions and posting content, which might include some live imaging from the 1-meter telescope tonight. We've actually been pretty lucky the past few days and have had a couple of clear nights, so looks like we might get one more clear night before the clouds roll in, and maybe some nice 1-meter observing for you all tonight. But Elena, how are you?
Yeah, I'm doing great. I'm also very excited about this possible change in the weather that will allow us to get some good imaging. It has just been such miserable weather this year all around, and there's so much great stuff to see. Mars is in the sky right now,
Yeah.
for example.
Venus was beautiful this morning. It's so bright in the morning
Yes.
sky. It was a really nice sunrise with Venus sitting there.
Well, and tonight we've got Mars at the moment just really, really close to one of the brightest stars in Leo, Regulus.
Hmm.
Um, so you get nice kind of red, white, blue sort of like combo of colors in the sky.
Yeah. And you also
Um,
don't need a telescope to see that, so that's always
yeah, and that's a fair point as well. With our telescope, we're actually too good, so you won't be able to see them both in the same image.
yeah.
Um, there are some advantages to having a wider field of view.
Yeah. Yeah. Um,
Um,
but yeah, we have quite a moon-themed show for tonight.
Yes, it's actually, we've got Mars in the sky. Mars has moons. Earth has moons too. There's moons all over our entire solar system, and I just think this is going to be a really, really fun theme, especially because, of course, we're just coming out of the strawberry moon last month, um, which was beautiful and big and full, and actually, unfortunately, a little bit red because of the fires, but.
Yeah.
Um,
Yeah, at
At
least
least it raises moon awareness.
yeah. And at least we don't have any more smoke from the fires right now. So,
Yes, knock on whatever you like, but
yeah.
it seems to be fairly clear.
Yeah.
And yeah, and there's all kinds of great moon stuff happening. I think you've got the first one.
Yes, I do. So for our this week in space and astronomy history, I'm going to go to June 19th, 2009, which was the launch of two NASA satellites to study the moon. One of them is the Lunar Reconnaissance Orbiter, or the LRO for short, and the other one is a bit the longer name, the Lunar Crater Observation and Sensing Satellite, or LCROSS. Now, like I mentioned, these are two NASA satellites, and we're actually the first NASA satellites to launch to the moon in over 10 years. So I'm not sure why they had this long 10-year gap before they went back to the moon, but kind of interesting that they were the first ones to go to the moon. Now, both of these satellites did have similar science goals, but they went about it in two completely different ways. But the gist of it is both of these satellites were meant to study the lunar environment, to look for different types of resources on the moon, which included water, and generally also to prepare for upcoming missions to the moon, which I think primarily refers to the Artemis crewed missions to the moon, which should be happening fairly soon, hopefully. But a bit about
Yeah, fingers crossed.
Yeah, at least Artemis 1 was a success. So now we just need the Artemis 2 mission hopefully coming soon. But um, yeah, just a little bit about each one of these missions in particular. I know the LRO is, just like the name suggests, a lunar orbiter, which was used to map the surface of the moon in very high resolutions. Now, this is a really awesome orbiter, has produced lots of really cool, pretty pictures of the moon because it created the highest resolution map of the moon, mapping 98.2% of its surface with at least 100-meter resolution. So there are actually some areas of the moon where it's mapped in higher resolution, which is just awesome. And in fact, the only areas of the moon that the LRO did not map are areas where it literally could not get pictures of the surface of the moon. There are certain areas, particularly in craters of the moon, that just never receive any sunlight. So there's no way to actually take images of those using a satellite. So really, those are the only areas of the moon that the LRO did not map. Now, included in the imaging that the LRO did of the moon, it spotted a bunch of the previous landing sites on the moon, including the Apollo missions. And because it was mapping the surface in such high resolution, it was actually able to take pictures of these satellites and these missions and the evidence that they had left on the surface of the moon. This included not only the moon buggies, so these are just like literal kind of cars that astronauts in the Apollo missions drove around on the surface of the moon. But not only could they see the moon buggies themselves, but they could actually see the tracks from the moon buggies on the surface of the moon, which is really cool. I definitely recommend looking up these images. They're awesome. And one link I can recommend in particular is this Lunar LROC quick map. If you just Google that, you should find it pretty easily, where they actually have all of the LRO images in this like easily accessible map. So you can zoom around, zoom all the way in on the moon, look at all of the small craters and interesting surface features, and even search for specific areas of the moon, including things like the Apollo or any other kind of moon missions, which is really awesome. Now, the next satellite, L-Cross, it had very similar goals to the Lunar Reconnaissance Orbiter, just understanding the lunar environment, but it went about it in a very different way. What L-Cross actually did is it was an impactor with two different components. There was first one component to L-Cross that would actually just go and crash into the surface of the moon. When it did that, it ejected a whole bunch of material off of the surface of the moon, which the second component of L-Cross, a satellite, would actually just fly through that material and analyze it. And the area that they picked to do this impact was one of these completely shielded areas on the moon, because this is really the only way to study it. Since it doesn't get sunlight, you can't do things like orbiters for that. So really crashing something into the moon and then flying through the debris is kind of the only way to get a good handle on the sort of compositions and stuff and chemistry and physics and everything that's happening within those permanently shielded areas. So the collision itself took place on October 9th, 2009, which was after L-Cross had been in lunar orbit for around 3 months. The upper stage that had been attached to L-Cross detached, impacted the crater Cabeus, which is in the south pole of the moon, and then ejected 350 metric tons of material. Around 4 minutes later, the L-Cross satellite flew through the dust to analyze its composition. It ended up finding a lot of really interesting things. So particularly, L-Cross found that these permanently shaded regions on the surface of the moon have tons of useful material. These include some elements in small amounts like mercury, magnesium, calcium, and silver. But also, potentially more importantly, they found a whole whack of water in the form of ice crystals in these permanently shaded regions. So that will provide or could potentially provide a very important resource for future missions to the moon, where they could potentially try and use some of that water in ice crystals in these permanently shaded regions on the moon. Now, while the L-Cross impactor, the mission sort of ended after that, the impactor itself actually did later impact the surface of the moon. They just sort of crashed it into the moon so it wouldn't interfere with other satellites or anything later. But the Lunar Reconnaissance Orbiter is still in use to this day, and it's going to be continue to be used until it runs out of fuel later this year. It currently has its mission extension until September 2025. It would need to get funding to continue past then, so hopefully it does get funding because the LRO is awesome. But yeah, that is a happy anniversary to the launch of the LRO and L Cross.
Yeah, and of course, if you had asked me 10 years ago, in the likelihood of us sitting around discussing water ice on the moon, I would have put it pretty low because it was one of those wonderful theories that people had, and we had just never tested it. And now that we're finding out there really is water ice in some of these craters, a lot of folks have gotten really, really interested about it. And I know that earlier this year, the Japanese space agency tried to launch another um, lander. They were going to send Resilience, and I think the potential landing site for Resilience was imaged by the Lunar Reconnaissance Orbiter camera a while ago, I think. But the actual Resilience did not make it, unfortunately. It is thought to have crashed earlier this year, but just the tremendous amount of interest that this water ice on the moon has. It's like
Yeah.
people are still trying. The Now I think Resilience was from a private company in Japan, but the Japanese Space Agency also sent some stuff, and of course the India Space Agency and Russia tried. Gosh, what was it? 2 years ago? 1 year ago now? So everyone's trying to get, especially down to that South Polar region, and be the first to get a piece of moon water. I
Mhm.
mean, how cool would that be? I mean, literally, but also, you would be able to bring and back and analyze a real piece of actual water ice from another surface in the solar system.
Mhm.
Um,
Is there not a sci-fi movie or something about or is
and
it
that one probably didn't end well, but
yeah.
there's there's definitely some sci-fi out there that would not indicate that we should be like drinking it. So if we do decide to use it, it will almost certainly need to be thoroughly tested. But yeah, the interest and the capture of imagination of finding a resource as rare and valuable as water on our own moon
Mhm.
um, just really goes to show that you shouldn't take anything for granted out there.
Yeah. Yeah. Yeah.
And I guess speaking of moons,
Yes. Which I think we could probably use two or three more times in the next half
yes.
hour, but
So going
yes.
from one moon to another,
Yeah.
I'll take us back in history as well. Now my back in history is just right around the same time as yours actually. So I'm going back to 2004 instead of 2009. June 11th, 2004 in particular, I am going to a moon that is not around Earth. This is when the Cassini spacecraft flew by the moon Phoebe. And this was a really interesting flyby for a lot of reasons. And Phoebe is a name of a moon you might not have heard of because it's not the biggest, it's not the most popular, but it is a very interesting irregular moon or satellite of Saturn. And of course, Saturn has its pick of moons, many, many large and small. It's known for having things orbiting it, but Phoebe is one of the more massive and potentially the most massive irregular satellite. So irregular meaning, of course, that it is, following an orbit that is irregular in some way. So if in astronomy, any kind of irregular moon or irregular satellite would be something that's going in an orbit that is either distant or inclined or retrograde or in some way interesting. Highly elliptical might be another one. But Phoebe is, it's roughly spherical, but very, very roughly. It's not massive enough to actually have formed a sphere like, our moon was, or, the Earth, or any other number of large bodies. You have to have a certain amount of gravity to do that. Um, but this one is, looks to have a differentiated interior. So that means that it was at least hot enough early in its history to start to pull heavier metals and things to its core, but it's not so big that it could really defend itself much against repeated impacts. And um, they think that perhaps it might be an object called a centaur, which is just a cool name for anything really. But for this particular object, a centaur is a small solar system body or object or moon or thing that would be between Jupiter and Neptune, and it crosses the orbits of those planets. And so these objects can be anything from sort of asteroid sized to kind of moon sized, and they're almost always unstable. And so if Phoebe started out there, that actually would explain why it is retrograde. And so having this large retrograde irregular satellite in Saturn has made a bit of a puzzle. And of course, as you go out into the icy outer solar system, we do get extra water ice in a lot of our objects, so they can be, lower density, interesting things can happen. And the flyby in particular, on this case, was really kind of a herald, if you will, for close-up studies of some of the moons. And Cassini-Huygens, flying by Phoebe on June 11th of 2004, was really just one of the many, many wonderful things that Cassini-Huygens was on its way to do around Saturn. I think it's easy to say that it's probably one of the most spectacularly successful missions that I can think of. The voyage to Saturn included all kinds of wonderful things that we probably don't have time to go into. But Cassini was made of two pieces. So Cassini-Huygens, of course, was the Cassini space probe, and the Huygens lander, which would go on to land on a moon called Titan. So again, bringing back the moons to this one. And if you're going to go exploring moons, Saturn is a wonderful place because it is absolutely chock full of moons. So Cassini-Huygens was, of course, going through, and on its way out, it did have flybys of Venus and some asteroids and Jupiter, and of course the Huygens module traveled with Cassini until it separated, and it actually separated on December 25th, 2004, which is just a little bit after this flyby. So this was June 11th, 2004. So this was, on its way into that Saturn system, flying by, learning all kinds of interesting things about as much as it could of course of Saturn. So there's, as I say, more than more than we can probably go into in one radio show. But I just thought it might be a little bit fun to um, give you some of the selected destinations for, of course, the Cassini-Huygens missions, which was Titan, which is the moon that Huygens landed on. And of course, Rhea, Iapetus, Ione, Tethys, Enceladus, or Enceladus, Mimas, Hyperion, Phoebe, which of course is the flyby that inspired This Week in Space and Astronomy History, Janus, Epimetheus, Prometheus, Pandora, Helene, Atlas, Pan, Telesto, Calypso, and Methone, or Methone. I'm never quite sure on some of these. They get the extra accent on the end of the E. And a little bit of extra fun, the Cassini-Huygens, in its mission, on its way out, it did actually pass somewhat by Earth's moon as well. So Um, a lot of great fun, and of course, a wonderful mission on its way out to Phoebe. Now, just in case anyone wants a little extra Phoebe facts, because we don't talk about Phoebe anywhere near as often as we probably should. It is smaller, of course. It doesn't have an atmosphere like Titan. It's not entirely very spherical anymore, but it was actually discovered quite a bit in advance of this mission. So we already knew Phoebe was there. We knew a little bit about its orbit because it was discovered um, in 1899 from photographic plates, ostensibly by William Henry Pickering, but this was probably part of um, his astronomer observation campaign, which, as you know, was, well, as you may have heard, was staffed largely by many interesting and semi-uncredited women astronomers. So there's a whole interesting thing we could get into about calculators. But Phoebe was discovered in 1899, and it was named to kind of follow along with some of the naming sort of nomenclature of the time. People were using Greek mythological names. So this was coming, from a name that was associated with the moon, and from Greek mythology, this would have been the sister of Cronus, which was the Greek equivalent of the Roman god Saturn. So that gets you your Saturn connection back there. And the IAU names that they pick actually have stated that any features on Phoebe have to be named after characters in the Greek myth of Jason and the Argonauts. So if you find a new feature on this moon, you have to name it after one of those characters, and it can't be one that they've already used. So they've officially named 24 features so far. If you have a name that you'd like to see, I guess start reanalyzing the data, and maybe if you find a new feature, you can get a name for it. Um, it is pretty interesting, and of course, it does have this unusual orbit, which gives it its irregular designation. So retrograde orbit, and just in case folks maybe haven't heard of that term in this way, retrograde orbit means that the moon goes around Saturn opposite to the direction that Saturn rotates. And this is a little bit odd because most of the moons will go around in the same direction Saturn rotates because they were sort of ostensibly formed together. So that's one of the reasons why they think that maybe it was captured. It came in from outside, and that's why it has this unusual retrograde orbit. And there are a lot of satellites with similar orbits that might be fragments of Phoebe from collisions that it has had in the past. So you could, in theory, kind of reconstruct Phoebe if you could bring all that debris back together. And the Phoebe ring is one of the rings of Saturn. It's tilted 27 degrees, and it goes around in in roughly the area of Phoebe's orbit. And they think that the particles are micrometeorite impacts, so smaller impacts on Phoebe. So it's very interesting little moon, despite being kind of one of many out there among the forest of Saturn's moons. It is not huge. It's about 213 kilometers in diameter, so all the way across, or about 132 miles. So um, a large-ish region. So it's like, I don't know, some the general area around abouts of Toronto. But you wouldn't get across Ontario or something like that. So it's interesting. You wouldn't want it to hit you. It's Saturn's ninth largest moon, but eighth most massive. And it is definitely not very round and nice. What we did find from, of course, the flybys is when you do look close up, it is a very cratered surface. It's really craters on top of craters. It almost looks like the moon that you might see drawn for The Little Prince, if you've ever seen the Little Prince books, where he's standing on this incredibly uneven moon. It turns out they do have moons like that, and one of them is named Phoebe. So I'll go ahead and stop there.
Yeah, I just looked up pictures of it. It is definitely a funky looking moon, but
Yeah, and it's of course I would be remiss if I didn't mention as well that upon analysis of the surface of Phoebe, they did estimate that there would probably be a large amount of water ice on this small moon Phoebe. A
mm,
little bit less unusual than water ice on our moon because it is on the other side of the ice line in the solar system, but still.
yeah. Yeah, I guess time for another mission out to Phoebe, but
Yeah, like if we make it even colder, we'll find even more interesting moons.
yeah. Yeah. But speaking of making things colder, we're going even further into the solar system now, and looking at the Pluto system. So the next This Week in History is June 21st, 2006, so kind of all around the same time, which is when two of Pluto's moons, Nix and Hydra, were officially named by the International Astronomical Union. So today it's known that Pluto has five moons. Its primary moon, or sort of the largest moon, I think it's pronounced Charon. Is that how you pronounce it?
I've always heard it as um Chiron.
Chiron. Okay. Everybody pronounces these things differently, but
Yes, we may need to do the official translation pronunciation guide on that one. Or but I think we can go with maybe Chiron.
Chiron. Okay, let's go with
Split
that for now.
split the difference.
Yeah. So Chiron is Pluto's largest moon. If you look at some of the Hubble Space Telescope pictures of Pluto, it's very, very obviously right there. But it also has a whole bunch of other smaller moons, including Nix, Hydra, Kerberos, and Styx, which are currently part of the four additional known moons of Saturn. Now, because Chiron is so bright and it's the largest moon, it was actually discovered in 1978. But the additional four moons are much smaller and much fainter than Chiron. So they weren't discovered until the Hubble Space Telescope started observing Pluto and the Pluto system in preparation for the New Horizons mission in 2015. So New Horizons did a flyby of the Pluto system again in 2015. And prior to that, there was this search using Hubble called the Pluto Companion Search Team, whose goal was pretty much just to see if they could find any additional moons of Pluto ahead of the New Horizons mission. And this is where the moons Nix and Hydra were discovered, was part of this Pluto Companion Search Team. They were actually discovered in around May or June of 2005, but around a year later, the International Astronomical Union officially gave them the names Nix and Hydra. So much like with moons in the Saturn system and Phoebe, there are certain rules that you have to follow when naming moons of Pluto or any other objects in the solar system by the International Astronomical Union. And in this case, their rules is that objects in the Pluto system have to be named after mythological creatures that are affiliated with the underworld. For example, Hydra, the Nyx and Hydra, one of the names came from the creature in Greek mythology who is a nine-headed serpent. And then the moon Nyx was named after the goddess of the night and the mother of Chiron, which also came from Greek mythology. Now, this is also a little bit of an interesting fact about the name Nyx. There's two ways that you can spell it. One is Nix, and the other is Nyx. Technically, Nix is the correct spelling in Greek mythology, but the name that they gave to this moon actually followed the spelling from the Egyptians. And this was just because there was another object in the solar system that was spelled the correct way. So instead, they decided to just change the spelling a little bit and swap out the Y from Greek mythology to the I from Egyptian mythology. So you don't have two objects in the solar system which are named the same thing. Now, on top of that, there's also a bit of a tradition. It's not a rule, but just sort of a general tradition that people have been following for a while, where they try to, I guess, sort of give a little bit of a shout out to the important people and important components that go into discovering these various moons. So the letters here, N and H, were chosen in part because of the New Horizons mission. So the N is the first letter in New, and then H is the first letter in Horizons. So they tried to pick objects or mythological creatures who had the letters N and H at the start of the words. Or alternatively, the H in Hydra could also be for the Hubble Space Telescope, which was used to discover them. And another sort of interesting thing about this naming tradition and naming convention is the P and L in Pluto were also chosen after the astronomer who started the search which led to Pluto's discovery, uh, Percival Lowell, I think is how you say his name. He was not the person who actually discovered Pluto itself, but he was the person who kind of initiated that search for Pluto. So the name was in part chosen after him. Now, Nix and Hydra, we know a lot more about them now after the New Horizons missions and additional Hubble Space Telescope imaging. Both of them are about 50 kilometers across, so very small moons, with Hydra being slightly bigger than Nix. And they're both about 5,000 times dimmer than Pluto, which is exactly why it took so long to actually find these moons and why they weren't discovered when Chiron was initially discovered as part of the Pluto system back in 1978. They're both also believed to have formed in the early solar system during a collision between Pluto and another Kuiper Belt object. So lots of interesting naming conventions, I think, when it comes to Nix and Hydra. It's very interesting because astronomers are, really terrible at naming things. So it's kind of funny to me that the International Astronomical Union has to sort of set some rules about this.
Yeah, yeah, there's a sort of hidden middle ground where it's like, okay, well, at least we'll have some agreement anyways.
Yeah.
Um,
Although I
but
am
yeah,
against
that's
some silly names, but
yes. Some of the silly names work out. Some of them do not. Uranus. But yes, Nix and Hydra and Pluto, they're all wonderful, spooky names for a truly spooky, cold, icy corner of the solar system. And I just love how you know, it's so very, very different out in the icy outer solar system. I think that, it's one of those strange effects that we kind of don't really pay a lot of attention to because it's so alien from what we're used to here on Earth. Pluto is so far out and it can't be heated by gravitational interactions or anything like that. And yet, it has mountains, and they seem to be made of some kind of ice. And I won't say water ice because at that cold, icy temperature, um, you get methane and nitrogen ice, and water is like bedrock. So, when at the temperatures of Pluto, which are extremely cold, I think was it minus 380 something Fahrenheit or minus 230 Celsius. Really, really, really cold. So cold that chemistry operates totally differently from what we know. Water is like bedrock solid, and you get methane and nitrogen ice, and some kind of unusual chemistry that can still form mountains with um, whitish looking caps. And I won't say snow caps because the chemistry is actually totally different. It's almost inverted because um, the atmosphere gets warmer with altitude. So if you go up on Pluto, the high up mountaintops are warmer than the surface because the methane gas absorbs solar radiation. But it's so thin that your surface temperatures are going to be constant with altitude, and so your winds go downslope instead of upslope like they do on Earth, and you get these weird totally different chemistries creating somehow similar landscapes, which I just love because the chemistry in the process is totally different. Pluto is so cold, it can't snow on the mountaintops, right? So the reason that they're a different color than the background is totally different. And I think uh, um, we do have a little more Pluto coming up later, so we'll definitely be talking more about that. But it is absolutely fascinating that you then have, these little possibly little collision moons, Nix and Hydra out there, and who knows how many other smaller little bits of Pluto might be floating around there after collisions.
Yeah. Yeah, the outer icy solar system is a very interesting place to be. But we do have another icy outer solar system topic coming up next. But before you get to that, we are actually live imaging now with the 1 meter. We were on Arcturus a second ago and now Vega. So definitely lucky with some clear skies. Um, but on
Yeah, absolutely. So for anyone listening to this over on Spotify or any of our other podcast channels, if you want to catch the live imaging, it's all recorded. Just make sure to go over to the YouTube OPV channel for the 1 meter live images.
yes. And on that note, I think we're back off to you for our last This Week in History.
All right. Yeah, absolutely. So we're one more to go, and then we're basically ready to to do the halfway mark. But yes, on this theme of moons, I'm actually going to sneak and go back to Saturn. So I teased a little bit earlier about that there was this really giant, interesting moon called Titan. But if I go way, way, way back in history, all the way back to the year 1655, on the 13th of June, or 3 days ago, but 1655, a very strange object was discovered. The moon Titan was discovered by Huygens. And the moon Titan, discovered by Christian Huygens, uh, was a really interesting discovery. Titan was the first known moon of Saturn and the sixth known planetary satellite. So Christian Huygens, a Dutch astronomer, he discovered this moon a bit after, of course, the four Galilean moons were mapped out by Galileo. So Christian Huygens made the discovery all the way back in 1655 using very early telescope technology. Um, the publication of the discovery was sent out on 13th of June 1655, and it was actually published as an anagram, which is this short little note. Very, very fun little way of writing out discoveries. And later on, it was actually published in more of an official manner in a pamphlet called De Saturni Luna Observatio Nova, because all of your scientific publications in Europe at the time were written in Latin. So you'll have to forgive my terrible Latin pronunciation here. So he published in a pamphlet, and then later on he published a full sort of full publication called Systema Saturnium, which is the Saturn system. And that was published later on in 1659, but he actually found it in 1655. And of course, as I say, would have been just the tiniest little dot that he would have been able to tease out next to the planet of Saturn. And he was actually studying the rings of Saturn. The rings were a really spectacular feature of Saturn, and so the earliest telescopes that could discern the rings were really having quite a battle trying to determine what the rings of Saturn even were. And of course, you had smallish telescopes, so you really couldn't see Saturn very well. So if you've ever seen a picture of Saturn, it's probably been a beautiful picture with clear, flat rings going around it from like maybe from NASA or maybe one of the fancy new JWST pictures. Really spectacular. But if you use a small pair of binoculars, like a very small pair, and you look at Saturn with those, well, it'll look kind of fuzzy, and you'll see that it's not round, and you'll see that it's kind of fuzzy around the edges, and it seems kind of fat, and it'll wobble a bit because of the air movement, and you won't get a clear picture of it. And so that's what Christian Huygens had, and he made several really big contributions to optics and mechanics as an astronomer, trying to improve the design of telescopes to make them better. Along the way, he invented the pendulum clock. So if you've ever seen one of those beautiful old pendulum clocks, that's you can thank him as well. It's one of the many side benefits of astronomy to the world, I suppose. He did quite a lot of amazing things, which we're not even going to be able to cover all of. But he had a theory of light for the wave theory of light, which we now know to be true. And he did incredible stuff. But my point about the telescope is that uh, he it really wasn't clear what was going on with Saturn. And some people thought Saturn might have had like two moons on either side following it around, or maybe it was like some sort of toroid, or maybe it was just some sort of optical illusion where it was actually some sort of full on just really fat planet. Um, so if you look in the old publications, there's debate about this, and people drew all of these crazy possible theoretical shapes for the rings of Saturn. And Huygens was out there investigating, and he was making improvements to his optics, his telescopes, and he found this tremendously nice a bright dot that seemed to be following Saturn around. And Titan is a little bit farther away than quite a few other moons of Saturn. It is the largest moon of Saturn, and it's the second largest in the entire solar system. It's the only moon that has an atmosphere denser than Earth. And it's the only place known to any human that has evidence of stable bodies of liquid. So nowhere else, anywhere in the solar system, nowhere else, anywhere in the universe, do we actually know of anywhere other than Titan and Earth that have stable bodies of liquid. Of course, I say liquid because Titan, it doesn't have liquid water. It's too cold. It has very interesting chemistry, which is one of the reasons why, of course, Cassini-Huygens was so keen to explore, especially Titan, this incredibly enigmatic, thick atmosphered, large moon. And it is by completely large enough to be round. It looks very planet-like. It has liquid hydrocarbon lakes. Um, and hydrocarbons are organic compounds consisting of hydrogen and carbon. So we know that it has organic compounds in it. Its atmosphere um, actually rotates faster than the planet itself. It's active somehow. It seems to have a geologically young surface, very few impact craters, and we think it has what are called cryovolcanoes, which is a, because it's very cold, a volcano that erupts gas and volatile liquids like water, ammonia, and hydrocarbons. So it could be that it's cold enough out there on Titan that the volcanoes spew water instead of lava like they do here on Earth. The atmosphere is mainly nitrogen and methane, and ever since it was discovered, we have been trying to find out more about it. It has been one of the most fascinating objects out there, and it's quite funny because one of the earliest names for Titan, which was published um, just after Huygens. So Huygens published his discovery and he sort of wrote it up into an official book. And Saturn went on to be observed by more and more people over the next, several hundred years. But along the way, there was a Italian Giovanni Domenico Cassini who published his discoveries of more moons of Saturn, and he began referring to Titan as Saturn's ordinary satellite, which I thought was quite funny because, of course, that's not really what he meant, but it is an extraordinary satellite. And the name, of course, Titan came a little bit later because they did realize eventually that it was fairly massive for a moon. And it is like Earth's moon in the sense that it seems to be in a synchronous rotation with Saturn. So it's tidally locked. It's a little bit different because Titan orbits Saturn once every 15 days and 22 hours. Earth's moon orbits a little bit slower than that. So it's quite interesting, and there's lots of orbital resonances and all kinds of great stuff you can read about it. But if you do nothing else, at least make sure to go and look up the amazing videos and pictures sent back from Cassini-Huygens and the Huygens lander in particular of the methane clouds wisping around the incredible landing site with those not at all rocks, the chunks of ice that look like rocks that they found when, of course, Huygens touched down on the surface in 2005. So really fun moon, really fun discovery, and still someplace we're investigating.
Yeah, I definitely have a lot to say about Cassini and generally just the moons in the outer solar system. They're so cool, but we're gonna have to move to the sort of midway point and on to our news because we have 13 minutes left. But for those of you who are just tuning in, you're listening to York Universe, broadcasting live from the Allan Carswell Observatory at York University in Toronto, Ontario, Canada. Please visit yorku.ca/science/observatory and follow the links to our chat if you want to see any live images. I think we're looking at Polaris now live with the 1 meter, and we were looking at Mars just a moment ago. But tonight you're listening to myself, Senna Withers, and Dr. Elena Hyde. We've currently been discussing moons in the solar system for our This Week in History. And we do have a couple of reminders before we go on to our news items this week. Did you want to talk about the Open Air Astro Fair?
Yeah, just really quick as a reminder to everybody tuning in, there is a one-time only super special event happening very, very soon. So June 24th to July 4th, the first clear day, we're running the open air Astro Fair at the Allan Carswell Observatory at York University in Toronto, Ontario, Canada. This event is dependent on clear skies. So whether it is a go or no go will be posted on the website, and everyone who has a ticket will get the email at 9 a.m. every day, June 24th to July 4th. And then once it's done, it's done. It should be a lot of fun. We're going to have a lot of telescopes. We're going to have a planetarium. The Astronomy Club is going to be doing henna constellation tattoos. So if you want to come out and see some really, really fun times, make sure to hop over to that same website you heard before, yorku.ca/science/observatory. And you can either add /astrofair or just click on the astrofair link on the main page. Tickets are available now.
Yeah. So very excited for that, actually. That should be a really fun event. But in another reminder we do have coming up is also the summer solstice is on Friday, June 20th. So this is the longest day and shortest night of the year. I am not a fan of these 9 p.m. sunsets, so definitely looking forward to starting to get some shorter days following the longest day of the year. But
Agreed.
yeah, yeah. But moving on to our news items, we have two JWST related news items, both related to moons. I'm first off this week with some new news on Pluto's atmosphere. Now, for those of you who don't know, Pluto has this very, very thin atmosphere, primarily made of nitrogen, but also has a few other molecules in there, including methane for one of them. It's been known since around the time of the New Horizons flyby in 2015 that Pluto's atmosphere is actually very leaky. It's leaking and losing about 2.9 pounds of methane every single second. And not only that, but around 2.5% of this leaking atmosphere is actually being captured by its moon, Chiron, and sort of igniting a lot of really interesting chemistry in the atmosphere and on the surface of Chiron. So it's the fact that the atmosphere is leaking and losing this methane is pretty weird and interesting in and of itself. But the thing that's kind of even more unique about this is the fact that this atmosphere is actually leaking onto Chiron, which is really not something that happens in our solar system. And I don't think there's any other known cases of one planet, or Pluto's not a planet, but one body with an atmosphere leaking some of its atmosphere onto a neighboring nearby body in the solar system. Now, in 2017, there were a group of astronomers that had theorized exactly why the Pluto's atmosphere was leaking so much. And what they kind of thought of essentially just boiled down to Pluto could have this layer of haze in its atmosphere that would be really good at absorbing ultraviolet light from the sun that hits the atmosphere. So it would absorb that light, it would heat up part of the atmosphere, which would give the leaking molecules essentially a bit of a kick of energy and enough energy so that they were able to actually escape Pluto's atmosphere. Now, specifically, this refers to methane and some other organic molecules in Pluto's atmosphere that would make up this layer of haze. On top of that, at the same time, it would also have a bit of a cooling effect on a part of Pluto's atmosphere called the mesosphere, which is one of the higher altitude layers of the atmosphere. So around the third, I think it's the third layer of the atmosphere would be called the mesosphere. So it's doing this interesting thing where it's heating part of the atmosphere and helping it dissipate, but also cooling another part of the atmosphere. And between the two of those effects, it could have a lot of implications on things like the surface temperatures on Pluto and potentially even some of the chemistry that happens there as well. Now, half of this theory that astronomers had come up with in 2017, the cooling of the mesosphere, was something that had actually already been detected previously. However, scientists had never been able to actually detect this layer of haze in Pluto's atmosphere itself. So they were kind of observing the effects of a layer of haze in the atmosphere, but they had never actually seen the haze in Pluto's atmosphere itself. Now, this was until JWST took a look at the Pluto system. Now it finally actually has a high resolution view of the Pluto and Chiron system. So it was able to kind of actually directly observe this haze in Pluto's atmosphere specifically. So what JWST did is it actually just observed Pluto in the mid-infrared. So these are just sort of sort of longer wavelength infrared wavelengths to be able to spot what's called thermal emission that comes from this haze in Pluto's atmosphere. Now, this is something that astronomers had kind of tried to do before with previous infrared telescopes, like, for example, the Herschel Space Telescope and the Spitzer Space Telescope. And while they were able to detect some of this thermal emission in the infrared from the haze in the Pluto system, they were never actually able to disentangle where exactly this emission was coming from. So is it coming from something on Chiron? Is it coming from something on Pluto? They just didn't have the resolution to actually be able to figure that out. But JWST does. So it has now actually, for the first time, detected a layer of haze in Pluto's atmosphere that is not only causing its atmosphere to leak into space, but it's also cooling some of the other parts of the atmosphere and having a lot of other implications for the sort of climate and weather that happens on Pluto. So very interesting discovery and kind of explains some unique features of Pluto's atmosphere and the Pluto system.
Yeah, and of course with all that interesting chemistry as well. It's just, I mean, it's so hard to get out to Pluto, but JWST observations are definitely the next best thing.
Hmm. Yep. But for our last few minutes, you've got another JWST moon story.
Yeah, I can just really quickly, I'll do this one more moon. So if it wasn't enough that JWST was helping us investigate a really, really interesting moon or binary moon, if you don't give Pluto planet status. Um, then what about finding out how moons are made? So JWST has been absolutely wowing many areas of astronomy, and moons are no different. So there have been a huge number of new insights into how exoplanets form in particular. And astronomers using the James Webb Space Telescope have recently published, and this is just about 6 days ago. Um, they call it Sand, Clouds, and Moon Nurseries is the name of the publication. But they got detailed images, really detailed images of two giant exoplanets orbiting a distant sun-like star. And what they found, and this is actually a little bit relevant to your talk about planets, you know, potentially giving each other atmosphere. Instead of atmosphere, they found sand-like silicate clouds in one of the planet's atmospheres and a really unexpected disk around another one. So we might actually be seeing forming moons in these systems. And because it's an older system, the planets already formed, something must have happened because generally you'd see moon formation in very young systems when, of course, the planets are still forming. So we have a couple really interesting snapshots thanks to JWST, potentially looking at the exoplanets, but also looking at their moons and how different atmospheres can actually look. And of course, if you know what the atmospheres look like, and you know what the moons are going to do, you can make models for different kinds of moon formation. One of the exoplanets in particular was the one that had the silicate clouds in the planet's atmosphere, and there was a circumplanetary disk that they thought was feeding material which could form moons around the other planet. So it's an interesting idea, and it might be an opportunity to watch and learn as something like perhaps a Jupiter type system starts to take place. And of course, directly imaged exoplanets outside of our own solar system are very, very rare. It's an extremely hard thing to do. These planets are typically still young enough that they're very, very hot, and it's the warmth that you want to see in the thermal infrared, especially with JWST. And that's, how you could possibly be able to get an image, before it cools down so much that you can no longer detect it. So they did get broad spectra of the two giant exoplanets, and the star, if you want to look up the system, is YSES1. The planets in question are fairly large, both of them several times larger than Jupiter, and they're orbiting at a far distance away from the host star, so they're not getting blasted like our planet Mercury gets blasted in our solar system. It does sort of showcase as well how different some of those planets are. So, of course, if you're looking to find out a little bit more about moon formation as well, that is also in the news and also sort of thanks to more wonderful JWST observations.
Yeah. Uh, moons with JWST, especially in other solar systems, it's pretty crazy that we could actually learn anything about exomoons in other solar systems. Because I know there's a couple JWST programs that are looking to observe exomoons as well. So yeah, very interesting. And I think that brings us, for once we actually made good time. It's 10 p.m. exactly. So for everyone, you have been listening to York Universe, the astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York University. The hosts this evening have been Dr. Elena Hyde and myself, Senna Withers. You can always connect with us on Instagram at the handle at York U Observatory and on Facebook at Allan I. Carswell Obs. And please check out our website for show notes, content, updates, and contact info at yorku.ca/science/observatory. Thanks for tuning into York Universe, clear skies, and have a good night.
Good night, everyone.